Hello College Algebra student, this video is for chapter 6.4 part 2, graph log functions. So in the first part we graph the parent function. We also analyze some of the main features of a log function, that is its domain is the inside of the log greater than 0. So we're going to graph a general log function. So the general one that we are interested in graphing would be a times log base b x plus c plus d. Okay, so we can certainly graph this by transformation, but before we do that, let's analyze log function of this particular form. What does it look like? So of course, the first thing we need to find out is the domain, right? The domain would be by solving x plus c is greater than 0. The range is always a real number because in the original exponential function, their domain is always a real number. So the range for all log function is a real number. So there's no need to find anything. The vertical asymptote is the boundary of c. So if you solve this, it will be x is greater than negative c. So the vertical asymptote will be the boundary x equal to negative c. Then the third thing is whenever you graph something, you want to find x-intercept, y-intercept. So y-intercept is easier to find because you just plug in x equal to 0. So if you plug in x equal to 0, you would have a log c plus d. It is the y-intercept. Now, if c is a positive number, then you have a y-intercept. If it is not, it's undefined, then you don't have a y-intercept since it does not exist. For x-intercept, you do the same thing. You solve for y equal to 0. So you plug in 0 equal to log base b x plus c plus d, and you solve this equation. If you can solve it, there is an x-intercept. If not, there is no x-intercept. So let's do an example. So this would be helpful for us to graph a log function, like a general log function. Let's see. We have f of x is negative 2 log base 3 x plus 4 plus 5. So first, we have to do domain, range, x and y intercept. So domain, I don't think we need to do range. Range is just all real number. Domain is always what? X plus 4 inside of this greater than 0. So x is greater than negative 4, all the way to infinity. So we can find the vertical asymptote range is negative infinity to infinity always. And then vertical asymptote is at negative 4, which is the boundary, right? X is equal to negative 4. What about x and x-intercept? So x-intercept is, no, let's do y-intercept first. Y-intercept is to set x equal to 0. So that means negative 2 log 4 plus 5. 4 is inside. Okay, so just plug it in and log base 3. Okay, log base 3, 4 plus 5. So you can put in the calculator. So it'll be 0 comma negative 2 times, log base 3 I haven't teach you how to do. So I think you can, I'll teach you later. So log base 3 over log 3 plus 5. 2.5, around 2.5, right? So you can solve it. And then what about x-intercept? X-intercept is to solve y equal to 0. So you say 0 equal to negative 2 log 3, it's right, quite long, x plus 4 plus 5. So you move this whole thing over there. So it is all positive 2 log base 3 x plus 4 equal to 5. To solve it, you have to divide by 2. So log base 3 x plus 4 equal to 5 over 2. Now, how do I solve this? So remember, we solved these kind of things before. If we have something unknown inside, we write it as a exponent, right? 3 to the this. 3 to the 5 over 2 is equal to x plus 2. So x is equal to 3 to the 5 over 2 minus 2. Okay, it's really long. So that is the x-intercept. It does have it. Okay, so let's do the other one. Domain. Domain is the inside positive, right? So you might wonder, oh, how can I do that? Yes, you can. Negative x is greater than 0. That means x is less than 0, right? If you times -1 on both sides, switch the inequality when you're multiplying a negative number. That means x is negative. So negative means from negative infinity all the way to 0. And also, it also means the vertical asymptote is still x equal to 0. So what you can input into here is all the negative number because negative is positive. Okay. So domain range is all real number. Negative infinity to infinity. Y-intercept is to set x equal to 0, right? But ln 0 is undefined. Undefined does not exist. So no y-intercept. What about ln x or ln negative x is equal to plus 3 equal to 0 for x-intercept. X-intercept. So that means ln negative x is equal to -3. So e to the -3. So you remember how to solve this when we had lots as 6.3. E to the -3 is equal to negative x. So x would equal to, so divide, so x would equal to negative of e to the -3. Put in the calculator, so you can actually find the x-intercept. So this does exist. Negative, okay, so e to the -3 is 0.05 and then negative, so negative 0.05. So x-intercept is negative 0.05 comma 0. Okay. So sometimes you have x-intercept, sometimes you don't have. The next thing is general log function. So graph a general log function by transformation. So for a very simple one, these are more complex. I think this one you can do transformation. So we use the transformation rule that we did. If it is adding c inside the function, it is shift left and right. If it's adding a number outside, it's up and down. So it's the same thing. Reflection is if it is inside, it's reflect over y-axis. If it's a negative, it's outside, then it's reflected over the x-axis. And the same for compression and stretch. I think most of the time we do this. Multiply outside is a vertical stretch. Multiply inside is a horizontal stretch, but it's the reverse. If you multiply by a number greater than 1, it becomes compressed. If you multiply by a number less than 1, it becomes stretch. So let's try. We're interested graphing this y equal to ln negative x. So this is a reflection, right? The original ln x we already graphed. Actually, we know that if the base is greater than 1, your parent functions are usually like this. It's all usually have a 1 comma 0 and also a b comma 1. B comma 1. Just the reverse of exponential. Exponential, you have 0 comma 1 and 1 comma b, right? For log, you have 1 comma 0 and b comma 1. So in this case, for log, it is e comma 1, right? It's e comma 1. So we have e is 2.7. So at 2.7, it go up to 1. And then it always have a vertical asymptote as x equal to 0. So this is the original, right? So this is the parent function of y equal to ln x. But ours is a reflection. So what we do is just every single one just reflect on this side, right? So instead of 1 comma 0, it will be negative 1 comma 0. Instead of e comma 1, it will be negative e comma 1. Okay. be a negative e comma 1. So that is L and negative x. Yeah. Okay, so the next page is a graphing more complex one. So we have 1, 2, 3, 4. We have 3 more to go. Can I finish it in 5 minutes? Let's try. So this is a law. What kind of transformation? So we say this is a transform. The types of transformation is from log 4x, right, by reflect and the vertical stretch, right? Reflect over x-axis and also stretch by 2. Stretch vertically by 2. A factor of 2. So graph the original one. Okay, let's practice. If it is log 4x, we would go this way because b is greater than 1 is always like this. We have a 1, 0 and a b, 1. Right? B, 1. In this case, it's 4, 1. So now if I do a reflect over the x-axis, so then it would become 1, 0 will not reflect, but this would be down, right? So basically it would be like this. And then we would have to go stretch 2. So that means instead of, so we still have 1, 0, and then stretch this by 2 is not going to stretch. This would become 4, negative 2, right? So it would be a little bit more down, right? So there will be a 4, negative 2. It used to be 4, 1, and then it will be 4, negative 1, but then you would go up like this. Okay, so that's how you just do a sketch. Oh, this one is easier. So this is a transformation from what? From log x. Log x means log base 10x, right 3, right? Because it's minus 3 inside, is right 3. So the original one is always like this, 10, 1, right? 10, 1 over here. Actually, it's really, it should be 1. And then 1, 0, 1, 0, 10, 1. Now, if you do right 3, that means all of these move right by 3. So the graph would look like, instead of 1, 0 would be 4, 0, right? The vertical asymptote become what? It was x equal to 0 become move right 3 also. It will be x equal to 3, right? And then you would have 4, 0, and then 13, 13, 1, right? Because all of them move right 1. 13, 1, and then 4, 0. So that's how it looked like. The shape stays the same, just the vertical asymptote move. Okay, can I finish this? So this is, this is a outside, minus 4. That means is the transformation is down for what is the parent one? For log 3x, right? For y equal to log 3x. So let's just graph log 3x as our baseline. Because it's log base 3, we still have 1, 0, all of them like this. And then we will have 3, 1, right? So down 4 means every single point. So you have a asymptote is still here. You just shift up and down. So your VA is still x equal to 0. So instead of 1, 0, you will have say 1, negative 4. So you can think of it as like the whole thing moved down. So you have 1, negative 4. If 3, 1 become 3, negative 3, right? So it's kind of like this. Eventually it would go up, but 3, negative 3. That's how you graph it by transformation.